Hello and welcome to this month's Altitude. I'm Fran Slater. I'm a Deputy Operations Supervisor at NATS, Sonic Control Centre at Terminal Control, and I'm absolutely delighted to be back as your host today to talk about a very special anniversary, and that is 10 years of time-based spacing. A decade ago, NATS became the first air traffic service in the world to introduce time-based separation in what was a groundbreaking collaboration with Heathrow Airport and Leidos UK. And here to tell that story today are some of the people who helped to make it happen. Andy, Ben and Norm, a warm welcome to Altitude to you all. And before we get started, a quick reminder to everyone watching that you can submit your questions at any time during the show, and we'll get through as many of those as we can do later on. So, let's get started. Introductions from everybody. Andy, let's start with you. Tell us about you.
Oh, hi, I'm Andy Shand. I'm business development lead for Leidos. For Intelligent Approach. But prior to that, I worked for NATS for quite a number of years, and prior to that for British Airways. So I've got quite a long history with the subject.
Lots of knowledge. That's brilliant. Thank you. Ben, tell us about you.
Hi there, friend. My name is Ben Sanford. I'm a product manager for Intelligent Approach, which means I'm responsible for sort of looking after how the product is developed, how it goes forward, and trying to make sure that our customers are getting a great service from the tool as they use it.
Brilliant. And Norm, let's say hello to you.
Hi, everyone. Norman Easter. I've been a controller in NATS for just about 25 years now. Heathrow and Gatwick approaches. I've been using time-based separation for 10 years. And for the last 5 years, I've been part of the development and ATC lead teams to make it better.
Fantastic. Thank you. And welcome to you all. It's great to have you with us. So, Andy, I'm going to start with you. So give us some basics. What is time-based separation? What's the big deal? Where did it come from? How does it work?
Well, so the need to address delays due to headwinds initially came up when NATS, British Airways and Heathrow Airport, we were analysing the root causes of delay and airborne holding at Heathrow in the early 2000s. And this led us to ask the question, what could we do? So at the same time, Eurocontrol and NATS research and development were starting to think about time-based separation as a concept. And put very simply, until we had TBS, all airports separate aircraft based on fixed distance-based separation on final approach, based on the wake vortex categories of the aircraft. The problem is that as you start to get a headwind, then the ground speed drops and the landing rate drops. It's a bit like walking the wrong way up a moving walkway at an airport. So the concept of time-based separation is really very simple. We keep the time interval between the arrivals the same as it would be in a 5 to 7 knot headwind, and we dynamically adjust the distance separation to recover the lost capacity that you'd see from headwinds. And the benefits were obvious when the system went live in March 2015, with over a 60% reduction in headwind delays during the first year, saving something like 115,000 minutes of airborne holding and some 80,000 minutes of air traffic flow management delays. And we continued to update the system after that, but more of that later on. That's
fantastic. So why was Heathrow the best place to deploy it? What was it about Heathrow? That's the busiest two-runway airport in the world. So, that's got to have been a huge challenge. Why there?
Well, Heathrow was pressurized. Actually, it's a pressurized environment to make that change in, but we had a customer in the airport, Heathrow Airlines at the airport, that were very much behind trying to improve the situation, which meant we had a pull, if you like, to go and do it. Now, the problem was nobody had done it before. We needed to be sure that it was safe to put aircraft closer together. We needed to develop the tools and procedures which would allow controllers to more safely deliver the more precise separations that we were looking for. To be sure it was safe to do that, we did 5 years worth of LiDAR data collection at Heathrow. We had some help from Eurocontrol. They gave us the LiDAR equipment. So we measured what the wake vortex behavior was like for 150,000 movements over those 5 years, both in ground effect and out of ground effect. And we proved that the wake vortex decays faster. So we also needed to be sure that we knew exactly what the winds were on final. So we built that into the tool. We have something called a glide slope wind condition service, where we take MODES data from the aircraft, and that's very much more accurate than a Met forecast. So Heathrow was a great place to do it because it's so busy. They really needed it.
Yeah, it really makes a difference, doesn't it? And seeing it operate day to day now, and I'm sure Norm will come in on this as well, the amazing difference that makes into just the number of aircraft we land and all the implications of that in terms of, environmental benefits, as well as, like you say, saving delay for customers, whether they be the airlines or the people on the ground. So that's absolutely the case.
Why Heathrow? Heathrow's scheduled to 99% of its declared capacity. What that means is when you get a delay first thing in the morning, then those delays knock on throughout the day. So you'd end up with delays and cancellations potentially. So what Heathrow really needed was a more consistent landing rate, irrespective of the wind conditions, and TBS delivered that. And then it was further augmented in 2018 when we moved to RECAT EU wake vortex separations. And it's that standard of TBS, which we now call intelligent approach, which is now also live in Toronto and Schiphol airports. And we further developed the system, and Ben will talk about that in a moment, putting pairwise in to Heathrow. Where was I on the night it went live? Well, actually, days 1 and 2 were a bit of a letdown because we had winds of 5 to 7 knots. So the airlines and ATCOs said, well, what's the big deal? But on day 3, we had headwinds at 4,000 feet in the TMA of up to 50 knots, and the system really came into its own. And a personal story: on the Friday that week, I was flying back from Glasgow down to Heathrow, and most of Europe was in meltdown with the delays due to headwinds. Actually, my flight arriving at peak time arrived 5 minutes ahead of schedule on stand. And I thought, having been involved with the project throughout, I thought, this thing really does what we expected it to. So that was perfect.
Which is brilliant. I'm sure that must have been a great experience to have that and know that was
fantastic.
The case.
Yeah.
Norm, tell me what it's like as a controller at Swanwick. What's your experience of using it?
So I was a trainee when it first came in. There was a bit of scepticism. Controllers can often appear resistant to change, but provided we know what the change is and what the impacts are, if it's going to benefit either us or the customer, then we can get behind it. I think over the last 10 years, controllers, very quickly, controllers got used to it. And as Andy says, a couple of days after first implementation, the winds were very strong, and we went from a group of people who couldn't really see the benefit to the tool to all of a sudden, overnight, you can see this massive change. You're keeping the landing rate up. You've got fewer aircraft in the stacks. You're not as busy potentially. I think over the 10 years, controllers have really got used to it, and they make good use of it to help out the customer.
Yeah, absolutely. Big change for the Heathrow approach controllers, big change for the Heathrow tower controllers, lots of work that would have had to have gone into the background of all of that, to make that all come together, and lots of people working on the project. I'm sure that's the case. So Ben, where did your involvement come in?
So I sort of joined a couple of years after TBS went live, joined the product management team and ended up being the intelligent approach product manager. We essentially took the ETBS system that was live in Heathrow in 2018 and said, this is a really useful tool. It's delivering great benefits at Heathrow, and there are other airports around the world where this could also really help out. So we sort of rebranded the system as Intelligent Approach and started talking to some of the major airports as to and ANSPs about how it could help them. So I sort of picked up from there and have been running with it ever since.
Excellent. We'll talk a little bit more about where else it's come in shortly. So, Andy, looking back over 10 years, where do you think this ranks among the achievements that you're most proud of in your career?
Oh, it's right up there. I think it's one of the not only because of the success of delivering the tool, but a fantastic group of people to be working with. So, the thing was, nobody had done this before. It truly was a world first going into Heathrow. It was a little bit worrying when we were sort of not, just about to go live. Actually, couldn't have hoped for a better implementation into service. And in fact, we asked the controllers about 2 weeks after it went live. We said, could we take the system out of operation during the day to make a small change to adaptation and put it back in again? And the controllers went, no, leave it in. You can make your adaptation change overnight. I think that was sort of testament to the fact that we used a core team of controllers to help develop the tool. And that was both from the approach controllers and also from Heathrow Tower that were instrumental in ending up with a set of tools and procedures that really worked and was simple to use and helped the controllers with their job. The other thing that I think is amazing is that we did a hell of a lot of work on obviously the LiDAR data collection and safety case and the concept, but then we decided we basically got approval to go and build the tool at the end of 2013, and we chose Leidos as the company to go and build the software. We went live literally about 13 months in the ops room. It was running in shadow mode in the ops room after we'd signed the contract with Leidos. So that is amazing to go from concept to a live operational tool, in a little over a year. So that was fantastic. We also had, I think, really strong support from Heathrow Airport and from the airlines. We needed the airlines to do some different stuff. So we needed the airlines more than anything to actually fly the speeds that ATC were asking them to, because it's no good if somebody slows down on final early, then the people behind them start to catch up, and you'll end up with go-arounds or lost capacity. And the airlines really helped us with that. They helped each other really improve, up their game, and deliver to the ATC speeds, and that really helped the controllers feel comfortable that they could put the aircraft right up against the markers to deliver the most from the tool. So no, it's fabulous project. I think it really is right up there in the very best things I've been involved in.
Yeah. No, that's brilliant. And know more about you. So we went from TBS then into sort of ETBS, the enhanced version, and things like that, didn't we? So what was it like for you to have been involved in it, to train with it, and to then work with it and see how things moved on?
Yeah, ETBS, when we went live with that, introduced the weight categorization change from UK6 to the RECAT EU scheme that had been developed as part of that LiDAR study. That was a particular concern for me and for a lot of controllers, where we'd been used to providing certain minimum separations between certain sizes of aircraft that overnight were changing. So as an example, heavy medium on the Wednesday was a 5 mil minimum distance, and on a Thursday with ETBS and RECAT EU, that was 4, possibly less if it was a strong headwind. So I personally was worried, I have to say. And then fairly quickly afterwards implementation, we realised that this is really good, this is working really well. We didn't see any increase in wake turbulence reports or encounters. Very, very good. But you can imagine that knocking a mile or two off certain separations at Heathrow, as Andy says, it's capacity constrained 98, 99%. Every time you have an A380 followed by a medium, you were saving 2 miles between the Wednesday and the Thursday, and that could be even an even greater saving depending if it was a strong wind or not. So using it is brilliant, I have to say. Once you trust it, it does exactly what it says in the tin.
Yeah, so Fran, I spoke about I gave a couple of numbers when we went live with TBS, so 115,000 minutes saved. When we went into ETBS, so we introduced Recat EU. We introduced another feature, which is ORD, so optimized runway delivery. So the tool automatically deals with the compression inside the final approach fix. As the lead aircraft slows to its landing speed, then obviously they start to catch up with each other. So that is modeled automatically. And with Recat, there are some pairs where the runway occupancy is more limiting than wake separation, so that we added into the tool a runway occupancy indicator as well. The net result of all of that was that we saw the delay saving or the holding saving increased to 230,000 minutes in the year after we went live with ETBS. We saw 47,000 tons of CO2 saved in that year. And we saw a capacity gain at the airport in excess of tactical capacity gain of 2 additional landings in all wind conditions with ETBS. So, and it was that standard that then went into Toronto and Schiphol.
And just so for anybody who's watching who's not a massive aviation enthusiast and doesn't get it, no, just talk us through the concept when you've got wake vortex. If you've got a big aircraft and then a smaller aircraft following it, so all our aircraft are categorized according to the size and the amount of wake they produce, aren't they? And so it's to do with the way that the turbulence comes off the wingtips of the aircraft, and that's so that's what we're trying to avoid, because that can make aircraft unstable if they fly into the turbulent area following another. Have I explained that well enough, do you think, for non-ATC types?
Yep. Basically, the bigger the aircraft ahead, the bigger the wake. It's dependent on the aircraft's weight and its wingspan, primarily. The wake dissipates with time, not with distance, which again feeds back into that time-based separation. If you know what time that wake is likely to degenerate over or dissipate, then you can factor that into the calculation. It also has an impact on the follower's size and its wingspan and wing configuration as well. But that's where we started to develop pairwise using the Eurocontrol Recat EU pairwise separations. I'm happy to talk a little bit about that. That's a little bit more nuanced than Recat EU. It gives us wake separation values between each arriving pair, so it doesn't matter if it's a heavy medium, if it's the same category, we still get effectively a wake interaction, and that gives you, and we have timetables for all of those. But for the 40 most common pairs, 40 most common aircraft into Heathrow, that gives you over 1,600 possible wake separation combinations. So there's no way a controller, a human, can do that. And that's where we developed ETBS into pairwise to give us indicator support on all arriving pairs, not just the wake and the runway occupancy time that Andy mentioned earlier. So now Heathrow pairwise went live in December. We have indicators on all pairs, plus a dependent runway, and those indicators guarantee us minimum separations when the leader gets to touchdown. It allows us to use more finely tuned wake separations, which again helps keep that landing rate up and increase the landing rate. We don't have actual figures yet because it's only been live for 3 months, but we're hoping the study is going to be done shortly. But from personal experience, it is making a difference. We had one day just before Christmas. It was a very strong headwind day, and a day that I'd expect to be landing about 39 per hour, and I was happily keeping 44 per hour. So in terms of service to the customer, that is incredible. On a very, very strong headwind day, airlines are able to keep the schedule better.
Yeah, and that makes a huge difference, as we say, not just for the airline customers, but for the people getting on the planes, which is what we all want to deliver, is a great service that's going to make that better for people. So that's great. Ben, let's come to you. So how did time-based separation then turn into intelligent approach, and where else have you taken it since then?
So yes, the intelligent approach system that we sort of rebranded. We've been talking to a number of countries and ANSPs. In 2022, it went live in Toronto. They put it on their operation, or Nav Canada put it in their operation. primarily because they have sort of 3 east-west runways and 2 north-south runways. So predominantly they like to operate easterlies or westerlies, but sometimes they have really strong northerly winds and they have to go onto those north-south runways. And so they're down one runway and they're working into a strong headwind, so their capacity would completely drop off. So they were looking at a tool that would help them maintain a much more similar capacity in that northerly configuration to what they would typically get easterly, westerly. And then the year after that, it went live at Schiphol. They have 7 runways. You'd think that would be plenty for anyone. But they have a lot of different restrictions on how they can use those runways, a lot of noise-sensitive communities, a lot of different interactions between the runways. And so they were aiming to try and deliver more consistent capacity on their preferred landing runway, and therefore have to offload less aircraft onto the noise-sensitive runways. And they had a similar situation to what Andy was describing on the sort of 3rd, 4th day when Heathrow went live. They went live on a very strong windy day in 2023, and they would normally have been landing sort of 31 or 32 aircraft per hour on their primary runway in those kind of wind conditions. I would have had to offload to their adjacent runways. They were still maintaining 36, 37 landings per hour on that runway, even in those strong wind conditions. They saw an immediate benefit. And I was going to say the system, thankfully, when we built it for Heathrow, we built it in a very configurable way. So it is a sort of standard product, which we can then configure for any airport. And we have a company that works with us called Think Research, who do a lot of the number crunching for us. And we'll look at the flight paths at each airport, the speed profiles aircraft fly, the runway occupancy times. And we basically just have to work through the different traffic patterns and traffic behaviors at each airport, and we can then configure Intelligent Approach to deliver the benefits to any airport around the world.
Wow, that's absolutely amazing. It really is a very special product, isn't it? That, from that world first back 10 years ago, and how it's moving on and what comes next. So what does come next? You know, like what's Intelligent Approach going to do next? Tell us how air traffic management can deliver for airports and aviation more broadly, and what's going to happen, you know, in the future.
Well, as you've probably noticed, those 3 airports, Heathrow, Toronto, and Schiphol, lots of runways, and we got really good at doing aircraft arriving on a single arrival stream. What we've now done, maybe Norm can jump in a second, is 2 weeks ago we went live with what we called advanced mixed mode at Gatwick. Gatwick is one of the world's busiest single runway airports. They have aircraft landing and departing all the time on the runway, and we wanted to see how we could sort of make the operation more efficient for a single runway airport. And so we sort of designed this advanced mixed mode capability, which allows us to tighten up the gaps between aircraft for that arriving and departing mode of operation. Norm, did you want to sort of cover that a bit more?
Yeah, I was going to say, Norm, tell us more about that.
Yeah, to be honest, you covered most of it, Ben. I went live at Gatwick on the 6th of March. Similar to Heathrow, we haven't had massive headwinds since. But it is a world first. We've got the mixed mode environment. We've configured the tool, as you say, it's configurable. We've configured the tool to mimic everything that we could do with Gatwick before we had time-based separation. So if you were doing 1 in, 1 out, or 2 in, 1 out, whatever combination of arrivals and departures you want to do, the tool can do that. And we've configured it in the first instance that all departures, a tool will consider it as a heavy departure. So there's room for improvement. And in the future, we'll be hoping to do optimized mixed mode, which means we will get departure information coming back from Gatwick Tower itself, or from the controller's departure sequence, and we can figure that into the tool, which will give us more optimum spacing. So if it's an A320 that's departing, then the tool will be big enough for an A320, so the spacing will be big enough for an A320. Similarly, if it's a 777, the departure gap provided by the tool will be enough.
So it's really taking all that information that we've gathered and kind of almost making the experience of controllers who kind of know how these things work turn into a tool that supports us by calculating the distances for us to make sure we can absolutely maximize the capacity at all of these airports. Is that fair to say?
It's absolutely, Fran. Core team of controllers on the design and development side, both tower and approach. They've been involved since day one, since Andy was running it back in the day for TBS. We've continued with that principle. You have a core team of controllers from all the watches providing input, providing guidance, testing the system. And similarly, when we go to different places to have a look at their setup, we speak to controllers, we run simulations, and we make sure that the tool does exactly what they need it to do.
So absolutely a huge collaboration with, we've got training teams, we've got procedures design people, we've got link-ups all over the place, just trying to make the air traffic management a better place for everyone so that everybody can get their flights and get them on time.
Yeah. So
Andy, what do you think's next for Intelligent Approach? Where do you think it's going next?
Yeah, before I say that, I think what I'd say is ATM generally is seen as a cost by airlines and by airports. But for the first time with Intelligent Approach, we've got a tool where those customers immediately see the benefits that they're getting from the tool. So it really is about getting the absolute most out of the available runway capacity, and without having to build new taxiways or new runways in order to do that. What's next, I think, is curved approach. So we're seeing airlines or airports more and more putting in RMP procedures where the aircraft can save a significant amount of fuel, improve noise. But in order to integrate RMP traffic with ILS traffic, then we want to push those indicators from curved approach out into the terminal airspace. And maybe Ben will want to talk a little bit about that.
Yeah, so
Excellent.
the curved approach capability will deliver a lot of benefit to airports and airlines in terms of an environmentally efficient operation. But there's a challenge in sequencing aircraft on multiple different curved approaches, and some aircraft that aren't curved approach capable still coming in on an ILS approach. Trying to make sure all those aircraft arrive at the runway centerline a safe distance apart from each other. And what the Intelligent Approach tool can hopefully deliver is indicators for the approach controllers to allow that sequence to be managed efficiently so that you don't have a potential loss of capacity while you're getting a benefit in environmental performance. So we want to enable airports and airlines to implement these curved approach procedures to get the environmental benefit without having the downside of a loss of runway throughput.
So Intelligent Approach really becomes more of a sustainability tool than just a capacity tool.
Yeah, absolutely. It's going to deliver all sorts of benefits to us, which is what we want to do. And we're constantly looking to improve the entire system so that we can make it better for the environment, better for the people flying. I think that's great. So we'll get to some questions very shortly. So just one last thing from each of you, perhaps then. So what's the one thing you'd really like people to take away from watching today's show? If you could kind of sum it up in one line, what would you like them to take away?
I think, Fran, just go and do it. We didn't have the option of doing that because the tools didn't exist. The safety case didn't exist at the time. It's now in ICAO, PAN's ATM, so they've now accepted time-based separation as a global standard. So frankly, just go and implement it because the results are, let me say this, you won't be disappointed.
Excellent. Norm, what about you? What would you say?
Yeah, echo what Andy says. And in my 25 years with NATS, there are two projects that stand out in terms of being outstanding, in terms of increasing capacity, making the ATM network better, and TVS is one of them. So again, go do it, and controllers trust it. If we've got 10 years using it, and if you factor in the 2 years or 3 years that Toronto and 2 years at Amsterdam have been using it, we're over 15 years worth of experience, and it is a really good tool.
That's fantastic. Ben, what about you? What would your takeaway be?
I guess I'd just say the Intelligent Approach is really designed to be a support tool for the approach controllers. No matter where you are in the world, the approach controllers have a tough job to do, and they're trying to get aircraft down on the runway as efficiently as possible. If we can help them get it as accurate as possible, we can take some of that thinking away from them so they can sort of plan a little further in advance. It helps the whole thing run more smoothly, and ultimately that delivers benefits to the airlines, to the airports, and to the passengers who are trying to make their connections or get home on time or get away on time. So it's really a help for the whole aviation system.
Absolutely, that's brilliant. We've had some questions come in, so I'm going to try and get through a few of those. The first question we've got is from, I hope I pronounced this correctly, I believe it's Marche, who says, how did you predict the delay reduction and how close was this prediction to reality? Maybe that's one for Andy.
Yeah, so I think we were aiming for about a 50% reduction in delays, and actually what we saw was a 60% reduction, which is fantastic. So we'd done the analysis beforehand, so we'd seen what sort of impact the different, looking at the wind conditions on various days and the traffic samples, we worked through that with analytics. So we were very pleased when we got to the end of a year's operation, looked at the actual data, and actually we'd outperformed our prediction in terms of performance improvement.
That's amazing. Ben, did you want to add anything?
Yeah, I was just going to say, as well as what we saw at NATS, NAV Canada had an interesting experience. They had been aiming for this improved resilience to wind on these northerly days, but they weren't expecting the level of improvement they got to their non-wake pairs. They've seen, since having those indicators on screen, every pair of aircraft, the controllers are much more precise on how they're delivering those gaps. So even on just normal standard days, they're getting a much more consistent operation, and the controllers are able to deliver a much more regular arrival spacing. So it's not just about those wind benefits which you'd originally been trying to mitigate. It's actually about getting a much more consistent and accurate operation at all times.
Which also then makes everything easier to plan for in the bigger system. And so we're much more ahead of the game, which really, really helps, doesn't it? Yeah, I get that. We've had a question from Sheila. How do you use TBS when operating dependent simultaneous approaches? Do you time off the aircraft on the parallel, or do you use a distance-based space between runways? I guess that's probably one for Norm as an operator.
Yeah, so when we were developing, so originally with TBS and ETBS, we didn't have indicators with the dependent parallels. If we were landing on the departure runway, then we would diagonally distance space it using your Mark 1 eyeballer off the graduated center lines. With developing pairwise, we had a set of criteria in terms of delivering minimum separations when the leader got to thresholds. And we were able to set that indicator so that the tool could back calculate and say, at this point in the approach, this is where you need to be in order to guarantee that minimum diagonal separation when the leader gets the thresholds. What we found, though, is that all the controllers in the simulations were aiming for the indicators, which is ultimately what we're trying to do as approach controllers. And if those indicators were spaced diagonally too close together, we would actually lose radar separation. So we've had to artificially cap those diagonal distances, those diagonal indicators, to minimum radar distance. Once you're established on the centre line, we have different rules. We have rules at Heathrow where you can still actually go side by side, provided you're in visual conditions. That doesn't happen very often, but we can still do it. So yeah, so the tool kind of does a combination of both. It is timed, but it's designed to give a minimum distance when the leader gets the threshold, and it's also capped at a minimum distance until the leader gets to 4 DME when that ORD compression starts to come off.
And Norm, I'm just going to carry on with you because we had a question from Ralph saying, how long did it take the controllers to adapt to using the markers? Was it a big change in operation for you?
I'd say not really. Controllers, the biggest difference or biggest thing is that you have to pick when to slow that aircraft down in much the same way that you would without indicators. You have to adjust for the wind. The approach controller needs to adjust for the wind on a given day. An aircraft will be more slippery than the next day because the wind's in a different place, and you get a feel for that. The tool is configured so that when it doesn't have live wind information, it's set for a slight tailwind, so it will add on additional distance and be conservative in order to guarantee minimum when the leader gets down towards the runway. Once I've got live wind information, the tool will then kick into proper time basin mode, and those distances will vary depending on the wind. Some days we have to slow half a mile behind the indicator so that by the time the follower has got its speed off, it's almost at the indicator. We do have procedures which allow us to go ahead of the indicators, but we try not to do that. In terms of getting used to it, it's pretty quick. The Heathrow controllers, it's been a step change from TBS, ETBS through to pairwise. So we've gone from just wake indicators to wake plus rot indicators, and now we've got indicators on all pairs. So for the Heathrow controllers, it's been that step change, and most of us have had that experience as we've gone on. We'll probably mention it in a little while, but we've just recently done the Gatwick implementation 3 weeks ago. But the Gatwick controllers are being very good at getting close to those indicators. They've gone from nothing to indicators in all pairs, and they are trusting in that tool and getting as close as they can to the indicators. It doesn't take long at all, to be honest.
No, that was really good. And I guess, the tower controllers would have had to adapt to, and that would have been a change in mindset for them. It would look different. Is that something you experienced with them, Andy? Did they talk about that with you?
Actually, the training for the tower controllers was really quite short. So I think they took to it very, very quickly. Typically, you want to be sure that you understand the background and exactly how the tool behaves, but really it kind of mimics their current operation. It just gives them some markers to allow them to see exactly where the minimum separation is. Funny story, we had the Toronto controllers, before they decided to go and put the system into operation, we brought them into the simulators at NATS and sat them down and said, why don't you have a go? Now, bear in mind, they were controlling. The sim was set up for Heathrow, so they were controlling a different airport, and they were using the tool with no training whatsoever. Actually, they were pretty good right from the instant. They could use the tool, so they really are sort of the guys have done a fantastic job making the tool intuitive and easy for controllers to use. I should say guys and girls, because it was probably a 50-50 split.
A really good team of people. We've got a question from James. Does Intelligent Approach also optimize the sequencing of aircraft to minimize pairwise separations and maximize landing rates generally? So I'll take on that. I'll let you go first.
Yeah, I'll take that one. So the way we operate in Heathrow, we have two controllers, one controller either side of one in the middle. The one in the middle is the one who's using Intelligent Approach and vectoring the aircraft to the indicators. The two either sides, they position the aircraft depending on the arrival manager sequence, and that attempts to optimize that sequence. The controllers will tweak it to try and max it. So if the arrival manager is giving us a heavy, medium, heavy, for instance, then we'll try and get multiple heavies followed by multiple mediums. You'll never get rid of it. But in actual fact, with pairwise separations, that becomes less of an issue, because the separations between aircraft get to the stage in strong wind conditions that there's no great benefit to having to worry about, if I've got one heavy here, if I move it 8 back in the queue, then I'll save a fraction of a mile. But that aircraft's then flying around the hold another twice. So there's that balance to be had as well. But yeah, in reality, with pairwise separations, there's even less of a requirement to sequence in that way.
Yeah, and we do have, as you say, an arrivals manager that starts the sequence for us, 200 plus miles out on the basis of where aircraft are coming in, that's monitored by the supervisory team, who also try to make the most of making the most of the vortex that we've got and the problems that we've got there to present to you guys on approach, and say again, you guys and girls, apologies, to all the controllers, what it would be that the best option that we can give you, so that you can then even fine tune it more, and then pairwise makes the best of all of that as well.
Yeah. And then that actually harkens back to my comment previously about the A380. With UK6, it would have been a minimum 7 mile gap. Plus, we would have given it an additional mile for the early speed reduction of the A380. It likes to slow at 5 miles. With RECAT EU and with time basing, we've gone from an 8 mile requirement to sometimes 4.5 with a medium falling. That's incredible. So that just changes the way you control round about that.
When you, Fran, just a point to make as well, because in the UK we went from UK 6 category to RECAT EU to pairwise. A lot of airports around the world are still using ICAO 3+1 CAT or whatever. So the change to go to RECAT or to pairwise and the benefit is potentially enormous. One of the things that both Toronto and Schiphol did was they used putting the tool in as a way of making it simple to go and move to RECAT EU or to ICAO 7 CAT in the case of Toronto. So you really can make a huge change to the operation by putting the tool in, which will support those changes to weight vortex separation.
Yeah, that's true. Understood. We've had a question from Sarah. Are there any conditions where you are unable to use TBS?
Provided all the systems are working and the aircraft systems are working, then the tool is designed to give minimum separations in all weather conditions.
Actually, with tailwinds, we do actually marginally increase the separation. And that's because if you've got a light quartering tailwind, that's the time when you're going to see the weight vortex persist for longer. So we've actually seen an improvement in weight turbulence encounters when we put the system live. So it's been live at all times since it went into operation on the 24th of March. So the answer is we use it all the time.
But just to be clear, there are occasions if you're switching runway ends, the system does need to regenerate the wind profile. So the first couple of aircraft, when Heathrow switches from easterlies to westerlies, won't have time-based separation. They'll still have indicators until the system has enough data to generate the wind profile on final approach, and then immediately switches back to TBS again.
Yeah,
correct.
And it's always going to work on the safest margins, isn't it? And then make sure that we refine and get better where we can, whilst making sure that margin of safety is in place, which is really, really important. So, and we've had a question from James. Has intelligent approach affected the number of go-arounds?
No, one of the design requirements is to make sure that you do not increase the number of go-arounds and losses of separation. Well, again, we've deliberately designed the tool to make sure that nothing on the screen would lead the controller in to having a loss of separation. So I'd say no to both of those.
I think the implementation of runway occupancy time was really driven by that requirement. There was no point getting aircraft closer and closer together on final approach, only to find that the aircraft ahead took too long to get off the runway and the following aircraft had to do a missed approach, which is why we then needed to show indicators to controllers to give them that guidance on how long we expected the lead aircraft to take on the runway so they could factor that in.
That's brilliant. And one for Norm, definitely this one. Andy says, did the introduction of TBS reduce the enjoyment of the controller? Are you now just trying to hit indicators rather than using your judgment?
No, because the indicators are just a graphical representation of where you want to be. You know, if you can just see over my shoulder there, that's the Heathrow approaches, and we've got graduated centre lines a bit like a ruler. And if you've got an aircraft at 4 and you're doing 3 mile space, and then the next one needs to be at 7, the next one needs to be at 10, 13, 16, and that's how we've always worked. We're still aiming for the same kind of spot. We can just refine it better. So I would say no. Some people might say it's dumbing down the job, but it absolutely doesn't. It doesn't change anything about how a controller needs to control the techniques they use. They still have to get aircraft there. I would actually say, if anything, it's allowing you to make aircraft or put aircraft closer together safely. And I say there's a bit more enjoyment in that.
Yeah, and I'd certainly echo that. All the controllers I speak to, they still are very much enjoying the job. At the end of the day, it's a brilliant tool and it's an amazing tool, but it is just a tool to support them in their skills in being able to move the aircraft as quickly as possible, as safely as possible to get everybody where they need to go. Yeah. Well, I think that's pretty much all we've got time for. I'm really sorry if anybody didn't get their questions in. Is there anything any of you gentlemen want to add as a last comment before I wrap up?
Say thank you for everyone for their help, the team that have worked on the tool. We had a little party on Monday to celebrate 10 years of TBS. It was very nice to see some of the old team back at Swanwick, they got to take a look at how pairwise and advanced mixed mode were performing and see how their little baby had grown up. So it's very nice.
Cool. Norm?
Yeah. Oh, go on.
Go and do it. For any ANSP, for any airport who's thinking of implementing it or might be interested, one of the first things to do is get a team of controllers involved from the get-go to make sure that what you get is what you need.
Brilliant. Andy,
yeah, of course they can come. Norm, they can come and see it in operation in Toronto, Gatwick, in Schiphol, if they want to see what it's like. What I would say is it's been a fantastic collaboration between lots of different entities. So between the airport, we had Eurocontrol support, we've had Cesar support, the airlines have supported, NATS, Leidos, Think. So all of that came together, and we couldn't have hoped for a better outcome. So again, I'd echo Ben's point about saying thank you very much. Fabulous team involved. Thank you.
Yeah. I think you're right. It's something we're all incredibly proud of. It's made a real difference to the way we operate and the things that we've been able to do. So I think that's absolutely brilliant. So thank you for everybody. I really hope you've enjoyed today's show. A big thank you to Andy, to Ben and to Norm, to all of you for watching and for putting forward some really good questions there. Really sorry we couldn't get through everything. Hope we've covered what you wanted to know. Don't forget that this show will be available on demand on the NATS YouTube channel, as well as on an audio podcast in all the usual places you get your podcasts. Keep an eye out on the social channels for details of the next show. And as ever, if you've got any questions or any suggestions about any of the topics you'd like to see on Altitude, then just let us know. Thanks very much for watching, and goodbye.